Welcome to Best Academic TV. In this video, we're gonna focus on Newton's third law of motion, and we are given a question here. But before we start solving this question, please listen to me carefully. Before we start solving this question here, I have to recap on Newton's third law of motion. In our last video, we stated the law of Newton's third law, and I told us that we have systems that obey Newton's third law, and one of them is elevator. Okay, now this is a question on elevator. Either I call it elevator or lift, they are the same. So now before we solve this question here, class, let's understand the question carefully. They said a boy weighing 60 newtons stands on a floor ready to move. Find the resultant force acting on him as the elevator moves upwards with an acceleration of 3 meters per second squared. We are giving G to be 10 meters per second squared. Okay. So whenever you have any question on elevator, question on mass block system, question on inclined plane, we apply the concept of Newton's third law. Okay, you can visit our video on Newton's third law, okay, to understand the concept of Newton's third law. Okay, now let's solve this question, class. Let's solve this question. Solution. Now the first concept on Newton's third law. First, let's draw a freehand diagram here on elevator. This is an elevator with a mass. Okay, under this mass, sorry for this, this is an elevator with a mass. There's a force acting upward on this elevator, and we call this force here tension. Please take note. In Newton's third law, in every action there's an equal and opposite reaction. Please take note. So I will have an opposite force to this tension here. Please take note. And that opposite force is a downward force, which we call weight, which is the same thing as mg. Please take note. So the first thing here in Newton's third law of motion, the first concept here in Newton's third law of motion is to identify, this is the system here, okay? It's an elevator. So it obeys Newton's third law, okay? Now, to identify the direction of the force of the system. So whenever you have one mass, to identify the direction of the force of the system, is always stated in the equation. That means when they say upwards, it means that the direction of the force of the system is going up. When they say downwards, it means that the direction of the force of the system is going down. But if I have two masses, the direction of the system will always go to the greater mass. So we are going to consider that later. All you have to do to get all the equations on Newton's third law, that is on an elevator or lift, inclined plane, and mass block system, is to hit the subscribe button. Okay, thank you. Now let's look into the question here. In the question they say upwards, that is the force of the system will move up. It's an external force, it will move up. We have this will be external force. This is the external force. It's not within the system, it's an external force. That is, it's upwards. Okay, so what's the next thing to do here, class, is to find the weight from the given equation and also find the mass. Okay, now let's find the weight here from the given expression here. They said a boy weighing 60 newtons. So that means the weight is already given to us from the equation, that is 60 newtons. So the weight of this is 60 newtons. stands on a floor ready to move, find the resultant force acting on him. That is the force acting on the guy. Okay, now this is the force acting on the guy. This is the force acting on the guy. That is this tension is acting on him. Okay, now let's continue. As the elevator moves upwards, that is the direction of the force, the direction of the system is moving up. That means the direction of the system is moving up. Okay, that is this particular sketch here is moving up. Okay, with acceleration of 3 meter per second square. So the acceleration given to us here, that is A, is 3 meter per second square, and G is given to us as 10 meter per second square. Class, if you look into this question here, mass is not given to us, but we can easily find mass here. How do we find mass? From the formula for weight to find mass here. So let's find mass here, class. So from the formula, weight is equal to mg. Weight is given to us as 60, is equal to mass. G is given to us as 10. Please take note. So making m the subject, I will have this to be 60 is equal to 10m. But don't forget this, that whenever you have an expression like this, that 2 is equal to, whenever you have an expression like this, that 2 is equal to s, is the same as s is equal to 2. So this is the same as 10m is equal to 60. So class, let's make m the subject. M will be equal to class 60 over 10, which will give us 6 kg. That means the mass here is 6 kg. Okay, so now let's form the equation here. How do we form this equation here, class? Okay, let's form the equation. Listen, please. Let's form the equation of this elevator. How do we form the equation of any elevator? First, we assign the direction of the force of the system. That is, you identify the first concept on Newton's third law is to identify the force, the direction of the force of the system. Okay. Now, the direction of the force of the system is up. So I will focus on this particular force here. Anything moving along with this force here will be positive. How do we know the force moving along with this? The arrow here is showing the direction. Please take note. So anything that is in line with this arrow here is moving with this particular force. Please take note. So what I will have here to form the equation here, I will have this to be F external. Remember, it's the total force, external force. F external is equal to, please take note, an external force. Now let's look into the system. Which of the force in the system, this elevator that is moving in the same direction with the external force, is tension? Please take note, that is tension. That means tension will be positive. It will be F external is equal to plus T. Now let's check the next force. Remember, tension and weight is also a force. So what direction is this weight here? Weight is moving in opposite direction to the external force. This is weight here. So it's going to be opposite, means minus. So this is going to be minus W. Please take note. So this is how we form the equation of weight. Sorry, this is how we form the equation of elevator or lift. Either I call it elevator or I call it lift. This is how we form the equation of elevator or lift. The first thing is to identify the direction of the system of the elevator depending on the equation. Please take note. If the equation is saying upwards, that means the elevator is going up. So the external force should be acting up. If the equation is saying downwards, that means the elevator is going down. That means the external force should be acting down. So after them, the external force will be equal to, depending on the force acting in the direction of the external force. If the force is acting in the direction of the external force, it will be positive. It is acting in the opposite direction to the external force, it will be negative. Please take note. So this is the equation for this elevator given to us here. Okay, now let's replace what is given to us here, class. From Newton's second law, we know that external force or resultant force is the same as MA. Please don't forget. So when you replace this, so this is going to be MA is equal to T minus W. And we are asked to find the force acting on the buoy. And the force acting on the buoy is T, that is tension. So let's replace what is given to us here, class. Let's replace what is given to us here. Mass is given to us as 6 times. Acceleration is given to us as 3 is equal to T minus weight is given to us as 60. So let's take light items here, class. 6 times 3 will give us 18 is equal to T minus 60. So making this T the subject of formula, we have something like this. From the question here, we have something like this. 18 is equal to T minus 60. So making T the subject of formula, that means I'll take this guy here, minus 60, from right hand side to left hand side. So I will have something like this, class. 18 plus 60 is equal to T. So 18 plus 60 will give us 78. So this will be 78 is equal to T. So in mathematics, whenever you have something like this, class, in mathematics, you have something like this, 2 is equal to S. Is the same as S is equal to 2. So this is the same thing as T is equal to 78. And tension is a force. But this force is acting on a syringe or on a rope. That means the unit of tension will be Newton. Okay, so the unit here is Newton. Please take note.